Hello and welcome to this video presentation on common tools for creating haptic content. My name is Bernardo Brogi from the University of Siena and I'm going to share with you some of the most popular software tools used for creating haptic experiences. To give you an idea of what to expect, let me first give you an outline of this presentation. First, I'll start with an introduction to haptic technology and I focus on two specific software tools, Unity and Chai 3D. Then, I'll show you how they can be used to create haptic experiences with some examples. Haptic feedback is a crucial aspect of creating immersive and digital experiences that can make users feel like they are truly interacting with the virtual world, rather than just observing it on a screen. As discussed in a previous module, the hardware components of haptic devices can vary depending on whether they are desktop or wearable. However, when it comes to developing haptic content, the software tools are of paramount importance. Game engines and simulation platforms play a crucial role in creating the haptic sensation that user will perceive and can greatly impact the overall quality of the experience. Out of the many software tools available for creating haptic content, we'll be focusing specifically on two powerful options in this module, Unity Game Engine and Chai 3D libraries. Both of them are suitable for different kinds of haptic devices. While Unity is more suitable for creating and developing the virtual environment, Chai 3D is particularly used for programming a lot of haptic devices in order to have a realistic feedback when touching the virtual environment. I'm going to start introducing the game engine Unity. Unity is a popular game engine used by developers around the world to create a wide range of digital experiences, from games to virtual reality simulations. Video on the left side shows the software environment, where cubes and spheres are being created and manipulated. One of the main advantages of Unity is its customization options, so it is possible to create any kind of virtual object or at least import 3D modules. Additionally, Unity is known for its integration with other software or hardware components such as head-mounted display or haptic devices. Another benefit of Unity is its user-friendly interface and a professional community support, which make it easy to learn from both beginners and experienced developers. Moreover, Unity provides an asset store where users can buy or at least download contents such as 3D modules or application. On the other hand, some disadvantages need to be considered. In particular, Unity can be very resource intensive, particularly when creating large or complex games or when a lot of different components are integrated in a single virtual environment. Another drawback is the cost of the software. Unity is a free software, but it has different plans. The personal plans is always free, but for users who need additional features, there are other plans which may have high costs. Finally, while Unity is designed to be user-friendly, there can still be a learning curve for new users, particularly those who are not familiar with game development or programming. Here I want to show you a brief video where a virtual playground environment with balls, buttons and planes is shown. The scene is entirely developed using Unity and the users wear an head-mounted display and a wearable haptic device. With the integration of the haptic device, the user can perceive the sense of touch and also temperature of the virtual world when he is manipulating them. However, the integration of the head-mounted display is crucial for the immersivity of the users. instead of using a simple monitor. Now I'm going to show you the main content of the simulation platform Chai3D. Chai3D is a powerful haptic rendering engine that is widely used by developers to create highly realistic haptic sensations. The video on the left side of the slide shows an example of a Chai3D environment where the object in front of the scene moves accordingly to a desktop haptic device. One of the main advantages of Chai3D is that it is an open source software tool, meaning that developers can access and modify the source code to fit their specific needs. With a simple and intuitive design, developers can quickly start creating haptic content. Another key advantage of Chai3D is its wide range of haptic device libraries, especially desktop devices. Moreover, it provides a multi-platform support, so for instance, it is possible to use two or more haptic devices together depending on the application needed. On the contrary, Chai3D presents some limited functionalities because it is primarily designed for haptic rendering and it is not as versatile as other game engines. It has already some pre-built environments that you can test freely, but it's not easy to customize the virtual environment itself. At the same time, Chai3D has a growing community of developers, so it has not the same level of experience, support, or resources available with Unity. Also for Chai3D, let me show you a brief demo of a user controlling two haptic devices simultaneously. The screen displays various virtual environments that use haptic feedback to simulate the sensation of interacting with objects in the digital world. This demo showcases Chai3D ability to create realistic and immersive haptic experiences that can be customized to a variety of different devices. Moreover, the demo showed the possibility of integration of different desktop devices, also at the same time. In conclusion, to wrap things up, we have explored two powerful software tools for creating haptic content, Chai3D and Unity. While these tools have different capabilities, they can also be combined to create highly realistic and immersive experiences. In particular, on the right side of the slide, it is shown an example of the combination of Chai3D's advanced physics engine and Unity visual design tools. The combination can be crucial for creating truly compelling haptic experiences. While developers may not always use them together, the potential for combining these tools is an exciting prospect for the future of haptic technology. With this, I concluded this video presentation and thank you very much for your attention.